Hi, my name is Kate Berry from the University of Texas at Austin, and today I'm going to talk to you about Pirate Math Equation Quest, specifically total problems. We talk about total problems in all three of our interventions: individual intervention with total difference and change schema, small group intervention with total difference, change, and equal group schema, and small group intervention for Texas word problems for grade 3 STAR. Every lesson in Pirate Math Equation Quest has 5 components. We have Math Fact flashcards, Equation Quest, Buccaneer Problems, Ship Shape Sorting, and the Jolly Roger Review. Notably, we talk about total problems in the Buccaneer Problems, Ship Shape Sorting, and Jolly Roger Review activities. Students identify total problems when they work with the teacher to solve word problems during the Buccaneer Problems. In Ship Shape Sorting, students identify cards as belonging to the total, difference, or change schema. And students talk about total problems in the Jolly Roger Review when they independently work to solve word problems. However, primarily we talk about total problems in the Buccaneer Problems activity. So today the focus of this video is going to be using total problems that are embedded within the Buccaneer Problems. To get started, we're going to need several different materials. First, we're going to need our run poster over here. We're going to talk about the run steps in the following slides. You'll also need a total poster. We also will talk about these steps in the following slides. You will need your Buccaneer Problems worksheet and a pencil or writing utensil. We have 4 different schemas we talk about: total, difference, change, or equal groups. You might first be asking yourself, Kate, what is a schema? We talk about schemas as problem types. We teach students to solve word problems by understanding that word problems fall into one of 4 different schemas: our 3 additive schemas, total, difference, and change, and our multiplicative schema, equal groups. We find that if students identify a word problem as belonging to a specific schema or problem type, then they are better equipped to solve the problems. Students are also better able to solve novel problems using the schema steps. As previously mentioned, today we're really going to be focusing on the total schema or total problem type. Today we're going to talk about 3 different kinds of total problems that students see during the Buccaneer Problems. We're first going to talk to you about a total problem where the total is the missing information. Next, I will demonstrate a total problem where one of the parts is missing. And lastly, I will demonstrate a 3-part total problem. Before we begin, I'd like to take a second to talk about the importance of gesturing. For all 4 of our schemas, total, difference, change, and equal groups, each of those schemas has a corresponding gesture. The gesture is meant to help students recall the information and help them to think, okay, a total problem means this because I'm following this gesture. The total problem gesture is when we have one part and another part, and we're putting those parts together for a total. Notice I put one hand out to demonstrate one part, a second hand out to demonstrate a second part, and then I clasp my hands together to demonstrate the total. I will show the gesture fluidly for you now. One part and another part, and we put those parts together for a total. As previously mentioned, we're going to talk about 3 different types of total problems in this video. We're going to talk about total problems where the total is missing, the part is missing, and we're also going to talk about a total problem with 3 parts. First, though, let's talk about a total problem with 1 part. And we have to look first at our total poster. For all 3 of these examples, we're going to use this total poster to help us to figure out the solution. For every total problem, we follow these same 5 steps. The first step is to write the total equation, which says P1 plus P2 is the same as the total. P1 stands for part 1, P2 stands for part 2, and T stands for total. Step 2 says find T, or the total. Sometimes we will know the total, other times the total will be missing information. Step 3 says find P1 and P2. That means find part 1 and part 2. Again, sometimes the parts will be missing and sometimes we will know the parts. Step 4 says write the signs. In every total problem, we follow use of the same signs. We use an addition sign and an equal sign, which we refer to as the same as sign. Lastly, we are going to solve for x. The final step is for us to check to see if our answer makes sense. So this is why we have this parrot here asking, does x make sense and why? So now let's go back and look at our first example. We're going to talk about a total problem where the total is missing. Here's an example. Let me take a second to get my dry erase marker so I can model this for you. Before students follow the total steps, we teach them an attack strategy called run. We have another video that features the run steps, and you can find a link to that description at the end of this video, so please feel free to refer to that video if you need more assistance and guidance on how to follow the run steps. Run is my attack strategy that I use for every word problem. We teach students to run through the problem. So I'm going to take a second to write the run steps. R stands for read the problem, so I'm going to read the problem. Mrs. Taylor bought 4 apples and 9 bananas. How many apples and bananas did Mrs. Taylor buy? I've read the problem, so I'm going to check that off. Our next step is U. U stands for underline the label and cross out irrelevant information. If you watched the run video, you'll notice that students underline the label in the question sentence. The question sentence is a sentence that starts with a capital letter and ends with a question mark. It says, how many apples and bananas did Miss Taylor buy? The problem is asking me about apples and bananas. It's not just talking about apples, and it's not just talking about bananas. So I'm going to take a second to underline apples and bananas because that is our complete label. I've underlined the label, but I'm not done with U. The second part of U is to cross out irrelevant information. I have to check all of my numbers and make sure that they're talking about our label. If I have a number that's not talking about my label, I know that that's irrelevant information, and that's information that I don't need to solve the problem. Our first number we see is 4. 4 is apples. Apples is about our label, so I know I need that number. The second number we see is 9. 9 is about bananas. Our label is also about bananas, so I also know I need that number. Now I can check off the U because I've underlined the label. The N in run, which is our attack strategy for every word problem, stands for name the problem type. We have 4 different types of problems. We teach students to ask themselves, are we putting parts together for a total, like in a total problem? Are we comparing 2 amounts for a difference, like in a difference problem? Do we have a start amount that increases or decreases to a new amount, like in a change problem? Or do we have groups with an equal number in each group, as in an equal groups problem? Here, I have apples and I have bananas, and I know I'm putting those 2 things together. So I know this is a total problem. So I'm going to cross off the N, and I'm going to put over here in the corner a T. That T is going to remind me that I'm using the total problem steps. Now that we have run through the problem, we're going to use our total poster. Once we identify the problem as belonging to the total schema, we follow the exact same total poster to help us come up with our solution. Step 1 says write P1 plus P2 is the same as T. Again, P1 stands for part 1, P2 stands for part 2, and T stands for the total. So I'm going to go ahead and do that right now. P1, or part 1, plus P2, or part 2, is the same as the total. Step 2 says find T. Now sometimes you know the total, and sometimes the total is missing information. Here, I have apples and bananas, and those are my parts. I don't know how many apples and bananas I have altogether, so that information is missing. When we don't know the total, we mark it with an X because our program is about pirates. And pirates find the missing treasure by marking an X. So I'm going to take a second to put an X under the T to show that the total is the missing information. Step 3 says find part 1 and part 2. I know part 1 is apples and part 2 is bananas. We're putting those parts together for a total. It's really important that students identify the parts as the words and not as the numbers. If students are thinking about 4 and 9 as the parts, they really might get confused. We really want them to be thinking about the objects as the parts and the total. So here, part 1, we have apples. I see here that I have 4 apples, so I'm going to put 4 under P1. And I kind of like to check off my number to let me know that I've already used it. Part 2 is bananas. I see here that I have 9 bananas. I'm going to put the 9 under part 2. I'm going to check off 9 to let me know that I've already used that number. Step 4 says write the signs. As we've discussed in a previous slide, all total problems use the same signs. We have an addition sign and a same as sign. I'm going to add those to my equation now. Step 5 says find x. We teach students to do something called isolate the x. That means to get the x by itself. We teach students to isolate the x in our second lesson component called Equation Quest. If you want to look at Equation Quest and look at our video for that content, you'll see more examples of isolating variables. But for this PowerPoint and for this demonstration, I'm just going to talk to you as if we already understand what it means to isolate the x. That just means we're getting the x by itself. So the first thing I do is I'm going to circle the x. That's going to remind me to see the x. Then I'm going to draw a line down from the equal sign. That's going to remind me to balance both the sides. I need that what's on this side to be the same as what's on that side. Here I see that the x is by himself. He's hanging out alone. He's not bothered. He's already isolated. When x already is isolated, I can go ahead and add these two numbers. 4 plus 9 is the same as 13. So I can write 13 is the same as x, or x is the same as 13. But I'm not finished. Every answer needs 2 things. We need a number answer. We have the number answer. We also need a label answer. All we need to do is look back up, because during the U and run, we underlined our label. We saw that our label was apples and bananas. So all I need to do is write apples and bananas. The last thing we have to do is check to see if our answer makes sense, because the parent is asking us, does x make sense? Why? In a total problem, our sum is always greater than the parts. The total is always greater than the parts. Here my total or sum is 13. 13 is bigger than 9, and 13 is bigger than 4, so I know that my answer makes sense. Now that we've talked about total problems where the total is missing, let's take a look at a second example. Students also solve problems where the part is missing. I'm going to demonstrate an example of a total problem where the part is missing. Whenever we see a word problem, the first thing we are going to do is run through the problem. This is the attack strategy we use for every word problem. And again, if you want to know more information about the run attack strategy, you can view the video that's linked at the end of this description. And go ahead and write run. The R stands for read the problem. Let's read the problem. The Oz family has 3 children. They also have 9 cats and dogs. If the family has 4 cats, how many dogs does the family have? We check off the R because we've read through the problem. The U stands for underline the label and cross out irrelevant information. I identify my label by looking in the question sentence. The question sentence is the question with the capital letter and the question mark. The question sentence says, if the family has 4 cats, how many dogs does the family have? The question is asking me about dogs, so I'm going to underline dogs. Dogs is our label. Okay, we've underlined the label. Now we have to cross out irrelevant information. So I need to scan my numbers and make sure that all of my numbers are talking about dogs or cats, because the problem is talking to us about animals. Let's look at the first number. The first number says 3. 3 is talking about children. Children's not about dogs, and children's not about cats. So this is irrelevant information. I'm going to cross out this sentence because I don't need the number 3. We've underlined the label and crossed out irrelevant information. Our next step, the N, stands for name the problem type. I need to ask myself, am I putting parts together for a total? Am I comparing two amounts for a difference? Do I have a start amount that increases or decreases to a new amount? Or do I have groups with an equal number in each group? Here, I know I have cats and I have dogs, and I'm putting those together. So I know this is an example of a total problem. To help me remember that this is a total problem and I need to follow the total schema steps, I'm going to put a T in the corner. I'm actually going to put it right down here. I'm going to cross off this N because I've named the problem type. Now, whenever we have a problem that belongs to the total schema, we follow the same 5 steps. Our first step, as shown down here, is to write the total equation. I'm going to go ahead and write that. P1 plus P2 is the same as T. Part 1 plus Part 2 is the same as our total. Step 2 says find T. Now, sometimes we know the total and sometimes the total is missing. In this problem, it says they have 9 cats and dogs. So we know our total. We know that they have cats. We don't know how many dogs they have. We know they have 9 cats and dogs together. 9's not just talking about cats, and 9's not just talking about dogs. 9's talking about cats and dogs together, so we know that we have our total. Our total of cats and dogs together is 9. I'm going to write 9 under T. I'm also going to cross off the 9 to let me know I've already used that number. Step 3 says find Part 1 and Part 2. We know that we're talking about cats and we're talking about dogs. Part 1 is cats. When I look here, I see that there are 4 cats, so I'm going to write 4 under P1. I'm going to check the 4 off, right there. Now, the question asks me about dogs. I don't know how many dogs we have, so I'm going to put an X under that because we're pirates in our program and we mark the missing information with an X. Now, in a total problem, when we have the part missing, it doesn't really matter if we put the X under Part 1 or Part 2. Okay, our next step, step 4, is write the signs. I'm going to go ahead and write the signs. Every time we have a total problem, our signs are the same. We have a plus sign and the same as sign. Step 5 says to find X. As we mentioned before, we find X by isolating the X. We want to get the X by himself. If you want to learn more information about isolating the X and working with variables, you can view our Equation Quest PowerPoint, which is linked in the description. But here, the first step is to circle the X. That's going to be so I can see the X. The next step is to draw a line down from the equal sign. This is going to remind me to balance both of the sides. I draw a line down from the equal sign because what's on one side has to be the same as what's on the other. Now I'm going to look at the X. The X is not isolated or alone by itself on this side of the equal sign. There is a 4 next to the X. To get rid of the 4, I see that there's a plus 4 here, so I'm going to put a minus 4 here. And that's going to give me 0. But what I do to one side of the equal sign, I have to do the exact same thing to the other side of the equal sign. So if I subtracted 4 on this side of the equal sign, I have to subtract 4 on this side of the equal sign. 9 minus 4 is the same as 5. Now I can bring this down. X is the same as 5. I have my number answer, but I'm not finished. I also need a label answer. We don't want our numbers to be lonely. Every answer needs to have a number and a label. In this problem, I can just look to see what I underline under the U in our run poster. I underlined dog, so I know our label is going to be dogs. I have our number answer and our label answer. The last thing I need to do is check that our answer makes sense. In a total problem, the total or the sum is always greater than both of our parts. Is 9 greater than 5? Yes. Is 9 greater than 4? Yes. So I know my answer makes sense. I'm going to take a second to erase this board, and on the next slide, I'm going to show you an example of student work where the student solved a total problem where one of the parts was missing. Here we see an example of student work where the student solved a total problem where one of the parts was missing. Here we can see the student underline the label, spin, and put a dollar sign to indicate that our label was dollars. All the way in the far corner, you can see that the student wrote a T to identify that this was a total problem. Here the student correctly wrote the total equation, P1 plus P2 is the same as T. The student identified 34 as the total because Gina spent $34 altogether at the post office. She spent money on packages, which is part 1, and stamps, which is part 2. Here the student put 19 because 19 is the amount of money it costs to mail packages, or part 1. Part 2, the student put an X because we don't know how much money Gina spent on stamps. Here again you can see that the student isolated the X, decided that the X was not by itself. If it says plus 19, we have to do a minus 19 to get the X isolated. If we subtract 19 from this side, we have to subtract 19 from this side, because whatever we do to one side of the equal sign, we have to do to the other side of the equal sign. So here the student subtracted correctly, and we have a correct answer, $15. We have a number in our label. We know that this answer makes sense because the total, or the sum, is greater than both of the parts. We've previously discussed total problems where the total is missing, total problems where the part is missing, and now we're going to talk about another total problem that students see and that we teach students to understand, and that's the total problem with 3 parts. Now I'm going to work a total problem with 3 parts for you. Every time we see a word problem, we run through it. We use the exact same attack strategy for every word problem. So I'm going to write our run steps here. Now we see something different on this word problem than we did in the previous 2. Here we see a graph. Whenever we see a graph, we teach students that we have to number or label the graph before we even read the problem. So let's look at the graph and number it now. The graph says tubes of paint in the art room. We have red, yellow, and blue. We also have a key that says each tube of paint stands for 1, 2. So what we're going to do is count by ones. Let's see. Red, we have 1, 2, 3, 4, 5. I'm going to put a 5 because we have 5 tubes of red paint. Let's look at yellow. 1, 2. We have 2 tubes of yellow paint, so I'm going to write that here. And then we have blue. 1, 2, 3, 4, 5, 6. We have 6 tubes of blue paint, so that we can know that that corresponds with the blue paint. Now that we've numbered our graph, we can go ahead and run through the problem. The first step is to read the problem. It says how many tubes of paint are in the art room. I've run through the problem. My next step is to underline the label. I can find the label in my question sentence. The question is asking me how many tubes of paint are in the art room. The question is asking about tubes of paint. So my label is going to be tubes of paint. Let's go ahead and underline that. We also, whenever we have a graph, want to make sure that we check the graph for relevant information. In our graph, we have yellow, red, and blue tubes of paint. Every number in our graph is talking about tubes of paint, so we don't have any irrelevant information. We just want to make sure that when we have a graph, students check both the story and our graph for relevant information. Now that I've underlined the label, I can name the problem type. Students need to ask themselves, are we putting parts together for a total? Are we comparing 2 amounts for a difference? Do we have a start amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Here I have tubes of paint, and I'm putting the tubes of paint together. I have red, yellow, and blue, and I'm putting those all together. Because parts are put together for a total, I know this is a total problem. I'm going to put a T right up there. You can't see that, so I'm going to rewrite it right here so that we can see that. The T is going to remind us that we are dealing with a total problem. Now, whenever I have a total problem, I just follow my total steps. Here, step 1 says write P1 plus P2 is the same as T. Just going to go ahead and get rid of that T so that we can really focus on our problem. Now, in this problem, I have red paint, yellow paint, and I have blue paint. In previous problems, we've had 2 parts, but this problem is different because I have 3 parts. I have red, yellow, and blue. In our problem, though, we only have 2 parts. All we need to do, though, is add a P3 at the front of this problem so that we have a spot for each one of our parts. I'm going to do that now. So in our total problem with 3 parts, I have P3 plus P1 plus P2 is the same as the total. Now I can just continue with my total poster. Step 2 says find T. Again, sometimes we know T, sometimes we don't know T. Here, the question is asking us how many tubes of paint are in the art room. We don't know the number of tubes of paint in the art room, so we're going to mark T with an X. We're pirates, we mark our missing information with an X. Step 3 is to find P1 and P2, and in this case, P3, because we are dealing with a total problem that has 3 parts. Our first part are the red tubes of paint. We labeled our graph to identify that there are 5 red tubes of paint. So I'm going to put 5 here. Now I'm going to check off the 5 to remind me that I've already used that number. Our second part is yellow. We know that we have 2 cans of paint that are yellow, or tubes of paint, excuse me, that are yellow. So I'm going to put that under P1, and I'm going to check it off. My third part is the blue cans or tubes of paint. I have 6 blue tubes of paint, so I'm going to go ahead and cross that off and put the 6 here. In a total problem, because we're putting parts together for a total, it doesn't matter really where you put the numbers as long as you get all 3 parts in there. Step 4 is to write the signs. In every total problem, our signs are plus and the same as. In a 3-part total problem, all I need to do is add another plus sign. Let's do that now. Plus, plus, the same as. Now what I'm going to do is add this to find x. The reason why I do that is because we already know that x is isolated. What we want to do is circle the x so we can see the x. Draw a line down from the equal sign to remind us to balance both of our sides. Here we see that x is alone. X is already isolated, so all I need to do is add the numbers on this side of the equation to get the answer. We always want to teach students to add left to right, so let's start with our first 2 numbers. We have 5 plus 2. 5 plus 2 is 7. So I'm going to put a 7 down there, and then I'm going to bring down this 6. I know that 7 plus 6 is 13, so our number answer is 13. We can also write it like this. X is the same as 13. I have a number answer, but I'm not finished. I also need a label answer. Our label answer is tubes of paint. I'm going to write T-O-P to stand for tubes of paint. Here we have our number answer, our label answer. We're almost finished. The last thing we have to do is to check to make sure our answer makes sense. In a total problem, the total is always greater than our parts. Here, 13 is greater than 5, 2, and 6, so we know our answer makes sense. Now that we've demonstrated how to solve a 3-part total problem, let's look at an example of student work. Here we see that the student solved a 3-part total problem. Notice at the first, the student numbered the graph. The student identified 6 snowy days in December, 11 in January, and 9 in February. The student underlined the label, snowy days. The student also checked for relevant information. Like I mentioned on the previous slide, whenever there is a graph, the student needs to check the story or the word problem and the graph or table for relevant information. Here the problem is asking us about December, January, and February. The question is not asking us about March, so notice the student crossed out March on the graph. The student also wrote the 3-part total equation, P1 plus P2 plus P3 equals or is the same as T. It doesn't matter if you put the P3 before P1 or after P2, as long as the 3 parts are in the equation. The student wrote each of the numbers under the corresponding parts after identifying that X or T was the missing information. The student solved by adding the 2 numbers on the left and then adding the number on the right. The student finished the problem by answering with 26 snowy days. The student also earned a sticker. Here you'll also see over here that the student ran through the problem with the R, U, and N steps. Now we will see a video of a student work example of a student solving a total problem. As you watch the video, I want you to pay close attention to how the student runs through the problem, reads it, underlines the label and crosses out irrelevant information, and names the problem type. Also pay attention to the fact that the student follows all of the total steps, writing the total equation, identifying T, identifying the parts, and also writing the signs and solving for X and checking that the answer makes sense. So as you watch the video, be sure to look out for those components.
What are you thinking? Nice job. Crushed it.
Thank you so much for watching our video. Today we talked about total problems in the Pirate Math Equation Quest intervention. We would like to take an opportunity to thank IES, the University of Texas at Austin, and the Meadow Center for Preventing Educational Risk. Without their support, this research would not be possible. Thank you so much for watching.